Probability basics. Probability for equally likely outcomes, F divided by N rule. Suppose an experiment has N possible outcomes, all equally likely. An event then can occur in F ways, has a probability F divided by N of occurring. Probability of an event equals F divided by N. F is the number of ways the event can occur. N is the total number of possible outcomes. Basic properties of probabilities. Property 1. The probability of an event is always between 0 and 1 inclusive. Property 2. The probability of an event that cannot occur is 0. An event that cannot occur is called an impossible event. Property 3. The probability of an event that must occur is 1. An event that must occur is called a certain event. Example: the accompanying figure shows the 36 equally likely outcomes when two balanced dice are rolled. We have the red die for the first one and the black die for the second one. We start with the red 1, the black 1, and list all the possibilities until we get to red 6, black 6. Determine the probability that the sum of the dice is 10. We start by writing the probability of the event, P parentheses, sum of 10. Then we look at our dice to see which sets add up to be 10. If 6 is first and 4 is second, that sum is 10. If 5 is first and 5 is second, that sum is 10. If 4 is first and 6 is second, that sum is 10. So that gives us a frequency of 3. So our probability is 3 divided by 36, which equals 1/12 or 0.083. Example: we are still using our 36 equally likely outcomes when two balanced dice are rolled. Determine the probability that the sum of the dice is even. So first we write down the probability of the event. Probability sum is even. We want to find all the combinations where we get an even sum. 1 is first, 1 is second, gives us 2. 1 is first, 3 is second, gives us 4. 1 is first, 5 is second, gives us 6. 2 is first, 2 is second, gives us 4. 2 is first, 4 is second, gives us 6. 2 is first, 6 is second, gives us 8. 3 is first, 1 is second, gives us 4. 3 is first, 3 is second, gives us 6. 3 is first, 5 is second, gives us 8. 4 is first, 2 is second, gives us 6. 4 is first, 4 is second, gives us 8. 4 is first, 6 is second, gives us 10. 5 is first, 1 is second, gives us 6. 5 is first, 3 is second, gives us 8. 5 is first, 5 is second, gives us 10. 6 is first, 2 is second, gives us 8. 6 is first, 4 is second, gives us 10. 6 is first, 6 is second, gives us 12. So we have a frequency of 18 out of 36, which reduces to 1/2 or 0.5. In this example, we have the same set of two balanced dice. Determine the probability that the sum of the dice is 3 or 4. First, we write down the probability of the event. P parentheses, sum is 3 or 4. Then we find all of the pairs that give us an answer of 3 or an answer of 4 when we add. If the first dice is 1 and the second is 2, that gives us 3. If the first is 1 and the second is 3, gives us 4. If the first die is 2 and the second is 1, we get 3. If the first die is 2, the second is 2, we get 4. If the first die is 3 and the second is 1, then we get 4. So that's 5 out of 36, or 0.139. Example, according to a survey, the distribution of graduate science students in doctorate granting institutions is shown to the right. Frequencies are in thousands. A graduate student is selected at random. Determine the probability that the field of the student selected is psychology. First, we write the probability of the event, P, and then in parentheses, psychology. Next, we need to know our sample size. You can always find your sample size by totaling your frequency. Physical science is 35.5, environmental sciences is 11.9, mathematical sciences 17.4, computer sciences 43.3, agricultural sciences 12.1, biological sciences 64.8, psychology 45.3, social science 88.3. Once we add those up, N is 318.6. Psychology has a frequency of 45.3. So our setup is 45.3 divided by 318.6. That gives us a result of 0.142. So the probability the student selected is psychology is 0.142. Example. We're still using the same survey as the previous example. This time, a graduate student is selected at random. Determine the probability that the field of the student selected is physical or social sciences. First, we want to write the probability of the event. P, parentheses, physical or social sciences. Our N is still 318.6. The physical sciences have a frequency of 35.5. Our social sciences have a frequency of 88.3. We want to add those together. So our setup is 35.5 plus 88.3 divided by 318.6. If you type that into your calculator, make sure you put parentheses around your numerator so it will add before it divides. This equals 123.8 divided by 318.6, or you can go straight to the answer of 0.389. So there's a probability of 0.389 that the student selected is physical or social sciences. Example. Still using the survey of doctorate granting institutions, a graduate student is selected at random. Determine the probability that the field of the student selected is not computer science. First, we want to write the probability of the event, P parentheses, not computer science. Since all probabilities add to be 1, one way that we can work this problem is 1 minus the probability the student selected is in computer science. Computer science has a frequency of 43.3. So we have 1 minus 43.3 divided by 318.6, which equals 1 minus 0.136, which gives us a final answer of 0.864. To recap, probability basics. Probability for equally likely outcomes is the number of ways an event can occur divided by the number of possible outcomes. The basic properties of probability is that the probability of an event is always between 0 and 1 inclusive. Probability of 0 means the event cannot occur. A probability of 1 means the event must occur, which is a certain event.